Mark Flayler here with a Autodesk University quick tip on multi-body modeling. Usually when you talk about multi-body, plastics are the first thing that comes to mind. Here we'll take a look at a more mainstream approach to using the multi-body techniques inside of Inventor 2010. Here I have the beginning of a vise base assembly, which currently has one solid in it, and that solid has two extrusions that make it up. They are created about the XY plane in both directions. I have sketch 3 here, which maintains a tolerance around the first extrusion. So basically just building in some of my design intent right here inside of one single file. Now this plate will eventually be another part by itself, but with multi-body modeling we can create everything here all at the same time and then generate our assembly components. So here I'm going to create a new solid for my slider. And now I have solid 2, which has extrusion 3 that makes up. Now what happens if I don't choose a new solid when I create geometry? Well, the normal thing that happens. This will just add material to an existing piece of geometry and not create any seams. So here you can see a join operation for extrusion 4, and that has been built in to solid 1. Now that's an easy fix. We can go back to extrusion 4, double click on it, and we'll change that guy right back to new solid. And now we have solid number 3. Solid number 3 is actually going to be yet another part inside my assembly for this. Now with multi-body techniques, we do have a lot of these new solid buttons appearing over some of our favorite commands like mirror. So here if I grab solid, choose my normal methods for doing this, pick the object and then pick my work plane, I can pick a new solid reference here. And this will create a new solid body on the other side. And this is parametric, so if my base gets longer about that XY plane, then both solids will update in their current position. Now if I want to start adding holes to this, I can do that too. Sometimes it may be hard to see for putting a tab hole in, so we can turn the visibility of our solids on and off, as you see here. Now I'm also going to add some chamfers to this. Now if I had added chamfers in separate parts, I'd probably go to at least 1, 2, 3, 4 different parts right now to add chamfers, and I have to remember which size I used for the chamfers going across multiple parts. If I was doing this in the context of an assembly, I'd have to open up different parts, add the chamfers, and then again make sure I had the right values each time. Here inside of a multi-body part, I can do all my chamfers all at the same time and see how they look together. Now when you go over here to this Make Components command, you'll find this on the Manage tab. Here I'm going to add 4 solids, and I'm going to put these into a standard IAM assembly. I can change the names, so instead of solid 1, which is really vague, I can give it an alphanumeric part numbering scheme. So basically what you're seeing here is every solid that was in my multi-body part file is actually going to be created as a new component inside of an assembly. I can also assign my own templates to it, my own bill of material structure, and I can even include parameters to go into my assembly in case I need to use that for constraint references or building something else with it. So here's my target assembly, and I have 4 parts automatically created and grounded, and if I double click on these you can see it's actually deriving in my original part. Return back up to the top here. The other nice thing that's great about this multi-body assembly here is there's 0 constraints. So that actually takes up a lot less load on your computer for processing constraint redundancies. Now here I am back in the part file, and I'm going to add a hole. Let's see, I'm going to go down 10 here. Let's go 15. Across from the side, I'm going to use some of my parameters here on this one. This one will be base divided by 2, and that's going to ensure that hole is always in the center of my multi-body part. And that's kind of a small hole. Let's make that a little bit bigger. Let's go 10 on that one. Now for this one, I'm going to tell it to terminate on that XY plane. I'll say OK. And you can see it added a hole to the first piece, but not the second one. Again, with most of our commands, we have a solids button inside of it. So we have to include participation of that solid for our hole in order for that to show up. Again, here I'll go and modify some of my chamfers because maybe they didn't look right to me before. I'll change some of my other parameters, such as the base width of my design, the base height. I'll change that up too. Let's move that to 35. I'll change my slider shelf to 15. That's a little edge there for my jaw. And for my base length, I'll change that to about 120. I'll make the change here in the multi-body part. Do the update. You can see I have a little bit of an issue with the hole there, so I probably have to go back and modify some of my parameters and how I'm creating some of my geometry here. But just for a quick fix, I'm going to make this a little bit closer to the top. Let's make that 10. That looks good for right now. I'll go back over to my assembly, hit my update button, and since these are all derived parts from that initial body, then they all update according to what was done in the previous multi-body part file. So you can see you can use this to eventually finish your design. Here I've added a couple bolts inside the assembly, a couple more parts, and these are all created inside the context of just the multi-body file. I'd like to thank you for watching this Autodesk University Tech Tip, and here's some information in case you want to check out some more of my videos, or if you'd like to follow me on Twitter or on my blog.